Good morning, students. Okay, now in today's class, we have to discuss that revision of fourth unit. So in the fourth unit, mainly we have to discuss regarding to the classification alternative techniques. In the classification alternative techniques, mainly we have to discuss Bayes theorem, or simply call it as conditional probability theorem, and an avian Basin classification and Basin belief networks. So here mainly three concepts we have to discuss with the fourth unit, that is the alternative techniques of classification. So in the alternative techniques of the classification, simply you can say that classification is a form of data analysis that abstracts the models describing the important data classes. So for example, here you have to consider you have the huge data, you have to analyze that data and which model you have to use exactly it is suitable. That classes we have to mainly you have to represent it with the data classification. Such models, what are the models we have to use to analyzing that data? And those are simply that models are called classifiers. And predict the categorical data, that is the discrete and unordered class labels. Example, we can build a classification model to categorize bank loan applications, either safe or risk. See here, that is the predict the categorizing data, that is the class labels, either discrete or unordered representation of the classification. Simply, you can say that classification is a form of data analysis of data. We have to analyze the data. For which models we have to use to analyze that data, that models are simply called as classifiers. So here, for example, you have to consider we can build a classification model to categorizing the loan applications, either safe or risky. Example, such analysis, we can say that it is the classification. Here you can provide with a better understanding of the data at large, and proposed by the researchers, machine learning and pattern recognition and statistics. We have to use it. So simply you can say that classification is to analyzing the data which models you have to use. That models are simply called as classifiers. Okay. For example, we have to take the real-time example. Analyzing the branch of the students. So which students are belongs to which branch, that you have to analyze by using this classification. Clearly it shows, like we have to take in the bank or loan applications, which application is safety and which application is risk. So how we can identify based on that CIBIL scores they have to identify. So greater than 600 we have that application is safety, and less than 600 where you CIBIL score is there. So you have to risk your application. So like that way you have to classify by using this classification. So here in the classification alternative techniques, mainly you have to use first one is the Basin classification, and second one is the Bayes theorem, and third one is the Navi Basin classification. So here Bayes theorem, Navi Basin classification, and Basin belief. So these are the three classification alternative techniques you have to use in data warehousing and data. First one, you have to consider the Basin classification. Simply, you can say that Basin classifiers are simply called as statistical classifiers. They can predict the class membership properties belong to the particular class. So Bayesian classification is based on that base. So whenever you want to analyze the data, here you can use the Bayesian classification. Here you can apply statistical classification. Statistical data only you have to consider. And mainly here you can use the predicting the class membership properties. So Bayesian classification completely based on that conditional property, or simply you can say that Bayes theorem. What is the Bayes theorem? So here you can discuss with the Bayes theorem. Let X is the data tuple in a Bayesian terms. Is X considered as the evidence? It is described by the measurements made by the set of data. So here you have to see H is a hypothesis of X tuple X specified class C. The probability of hypothesis of X is equal to, that is the conditional probability, P into the P of X hypothesis with the P of H divided by P of X. Here you can hypothesis can determine probability of H by X, the probability that hypothesis H holds given the evidence of the observed data tuple X. The posterior probability and posterior probability of the H condition on X. The Bayes theorem mainly have to represent a conditional probability, posterior probability, probability of H by X from the probability of H, probability of X by H, and probability of X. So here you can represent this. This is the conditional probability of the Bayes theorem. And next one is the Navi Basin classification. In the Navi Basin classifier are simply called it as simple Basin classifier. It works like P and the classes of C is some C1 to Cm. Probability of C of 1 to C of M, that is C of I of X, is always greater than C of probability of C of J of X. So always the first value, that is the C of I value, is greater than the C of J value. The Bayesian classifies products that same tuple X belongs to the class C of I. One only probability of C of I of X similar way, probability of is always greater than probability of C of x. For I is less than equal to j, less than equal to, yeah, j is not equal to I. We maximize that C of I by j by x. The class C of I is for C of j by x is maximized. It is called maximum posterior hypothesis. This is the posterior hypothesis. How we can find out the value? The probability of C of I x equal to probability of x C of I, probability of C of I divided by probability of x. So here you have to see this probability of a constant of all classes. So here many attributes are extremely computationally. We maximize the probability of x by C of I, probability of into probability of C of I. So probability of C of I is equal to probability of xk into C of I. The summation of that is C of summation of k equal to 1 to n. The product we have to represent probability of x1 c1 into probability of x2 c2 by the also probability of x1 xn c of. So you can find out the probability, estimate the probability value from the training tuples. So finally you can get that value, estimate the probability of training tuples. The categorical or continuous value you can find out. So for example, here you have to see the diagram. It shows this is the Bayes theorem, Navi Basin classification. Example, here this is the youth, middle-aged people, senior people are there. So in those all age of people, or what their income, and he is the student or not, we have to represent what is the credit rating, and he have the buy the computer or no, yes sir, that you have to. So this is the data you have. From this data you want to, whenever you have to apply the basic classification for this trained data, now you want to consider which people are buys the computer, that you have to identify. Buys the computer two distinct values, namely yes or no. Let C1 is corresponding to buy the computer S, and C2 corresponding to buys the computer. The tuple we have to classify. See these attributes: x equal to age equal to youth, income is medium, and student is S, credit rating is fair. We need to maximize probability of x by C of I, probability of C of I for I equal to 1 to 2, and C of I is peer probability of each class, can be computed based on the training tuples. Probability of buys the computer is equal to S, or probability of buys the computer no. So totally how many records are there? Here we have the 14 records. So in out of 14 records, how many people they have to buy the computer? That is the S 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally 9 people buy the computer. So that is the 9 by 14. We have to find out the probability. That is the buys the computer, probability of buys the computer as 9 by 40. That is the value you are getting 0.64. Yeah, this is the probability of to buy the computer out of 14 people. What is the probability of buys the computer is no. So what are the remaining people are there? No, that is the 5 people. 5 by 14. Here you have to get the probability. Points 357. Clear? This is the probability of buys the computer. No. So you have to both will be added to get the one always. Similar way, this is works like dice. One dice you have to roll. What is the probability of getting 6? What is the probability out of Total faces are there, 6 faces are there. What is the probability of getting 6? 1. That is the 1 by 6. Okay. Like this way, you have to find out. You have to find, you want to find the probability to a dice you can roll 2 times. What is the probability of getting chance of 6? And 2 times roll చేస్తున్నాడు కాబట్టి what is the probability? 2 into 1 by 6. That is the 2 by 6. 2 by 6 means 1 by 3. So that is the probability of getting the 6 on a dice. If the dice is rolled 2 times, మనం 2 times మనం dice roll చేస్తే what is the probability of getting 6 is that is the 1 by 3. Okay, clearly it shows that that is the probability way you have probability you can find out in Bayes theorem. So here Basin classification, that is the we have to apply it here. That is the Navi Basin classification. The Navi Basin classification we have to apply it. Out of 14 people, 14 records, 9 people are by the computer. Only 5 people are don't by the computer. So 5 people are that is the 9 people are by the computer. That is the 9 by 40, and 5 people are by the computer. No, that is the 5 by 40. So you get the probability 0.35. So now you have to compute the value P of x by C of I for I equal to 1 to we compute the following conditional problem. If the age is youth, buys the computer S. Age is the youth, buys the computer S. Okay. So here total how many people are there to buy the computer? 9 people are there. Now out of 9 people, who are the people are youth. So if they buy the computer S and his age is youth. So first one is S is there is middle age, no. S senior, no. S senior, no. Here middle age, no. Here youth. This is the person who is youth. This is only you have to consider. He can buy the computer and his age is youth. There one. And similar way, he buy the computer. Next one is senior, no. Here he buy the computer. Here you have the youth. So 2 people are there, and remaining out of 9, only 2 people are youth. So that is only we have to consider. That is the 2 by 9. That is the value you are getting 0.222. You have to. This is the probability you have to find out. That is the conditional probability you have to find. Similar way, income is medium and he buys the computer S. So here you have to check it out. Income is medium. So here you have the medium. He buys the computer 1. Here medium, no. So you don't want first. Here you have to consider. Here also you consider S. Here also you have to consider. So totally 4 people income is medium. They buy the computer. So here that is the 4 by 9. You get the probability 0.444. So this is the way you have to find out the conditional probabilities for the various attributes. So buys the computer S, what is the probability? Buys the computer no, what is the probability? What is the probability of age is equal to youth, and also or buys the computer is S, or buys the computer S, income is medium. So like this way you have to find out the probabilities. If the student is S, buys the computer S, credit rating fair, buys the computer is. So these are the probabilities you have to find out. Conditional probabilities you have to find out. Clear? This is the computer buys the computer S cases. These are the buys the computer no cases. Yeah. This is the conditional probability you have to apply for the given date. So next one, use these probabilities we can obtain the probability of X or buys the computer S. Okay. How many people or buys the computer? What is the problem? You can find out the probability if the age is equal to youth, income is medium, student is yes, red rating is pay. So here you can find the product, the probabilities we have to get in. All the probabilities we have to multiply. You can get that probability, that is a 0.00, and similar way by the computer. So all the probabilities we have to apply. So these are the probabilities. You can get the value 0.00. So this is the formula you can represent it for. This is the formula. You have to represent it as Navi Basin classification. In the Navi Basin classification, you can perform like this. So finally, you can get the probability of getting the purchasing the buys the computer yes and buys the computer no. Find the class C of I, that P of X by C of I, probability of C of I. We compute the value. Buys the computer S, buys the computer S. So 0.044 into buys the computer 0.643. That is the value 0.28. Buys the computer no, is buys the computer no. With the all activities, this is the X bar buys the computer S. Is the only buy the computer no. Buys the computer S. So you're getting the value 0.028, and here you can get the value. So here you have to getting the value. Probability of X bar C of I into probability of C of I divided by, that is the value you are getting, that is the probability of C of I. So 0.028 into 0.007 divided by 0.007. We can get the value. Therefore, the Navi and Basin classification predicts the by the computer S for the tuple X. Okay, this is the value you have to compute the values using this formula for the Navi and Basin classification. So finally, you can get the values like this. This is the example for this data. Exam point of view, they will be asked. Given data like this. You can find out the Navi and Basin classification values. So like this, we have to find out the probabilities, and you can multiply those values. And if the by the computer S, you can find the probabilities. By the computer no, you can find the probabilities. Finally, you have to multiply these values and get the by the computer S is the original by the computer probability. By the computer S, by the computer no. This is regarding to the Navi Basin classification. Next one is the Bayesian belief networks. In the Bayesian belief networks, mainly probability testing graphic models, which like analyze the Navi Bayesian classification, representation of dependencies among subsets of attributes. So here in the belief networks, mainly we have defined into two components. First one is the direct cyclic graph, and that is simply you can say that set of conditional probability tables. Cyclic graph and conditional probability. So see here, this is a diagram which shows that independent of descendant and non-descendants graph, and what is the family history and lung cancer, smokers, dyspnea. So this is the generally simple Bayesian belief network, a proposed causal model represented by the directed acyclic graph. This is the directed acyclic graph. This is the conditional probability of table of the values of value lung cancer, that is LC, showing each possible combination of the values, its parent nodes, that is the family history and smoker, uh, family history, smoker, the conditional probabilities. So this is the simple Bayesian classification. See, the example shows that this is regarding to the Bayesian belief networks. So once you have to revise this one, I will do the one example. How to how to find the probability for the given data. You can solve how to pick it up once. To follow this problem, take this example and you can find out the probability. Credit rating is fair. That is the credit rating is fair or excellent. So that is the probabilities we have to find out, and you can find out the probabilities. You have to check in the values. Here only two values are there. One is the credit rating either fair or excellent. So you have to consider here, find out the credit rating is fair. You have to find out the probability, and the credit rating is excellent. do that problem. We have to find out the probabilities. So totally, how many people have the credit rating pair? 1, 2, 4, 5, 6, 7, 8. 8 people have the credit rating is fair, and excellent is 6 people. So based on that, we have to find out the probability. 8 by 14 or 6 by 14. So get the probabilities. Then similar way, age is youth, credit rating is fair. Age is youth, credit rating is fair. Income is medium, credit rating is fair. Student is S, credit rating is fair. Buys the computer S, credit rating is fair. Similar way, age is youth, credit rating is excellent. Same you have to apply. You can get the probabilities and find out the values. The P of X by credit rating is fair. P of X by credit rating is excellent. You can find out the probability. So finally, you can get the probabilities. Do that one.